Okay, good evening, everyone. This is the sixth live session of Geotechnical Engineering 1, and today's topic is flow through soils, quicksand condition. Now, like the previous weeks, we are going to discuss some questions. First of all, I'm going to dictate the questions to you. You are going to write it down. The questions has MCQ, MSQ, and numericals. Write all the questions down at first. I'll give you 10-15 minutes time, solve those questions, and then I'm going to discuss all the answers. Okay, so I'm starting right away discussing the questions. Yes, the first question is, quicksand condition occurs when? You have to tell the condition for the occurrence of quicksand condition. The options are: effective pressure becomes less than 1, effective pressure reduces to 0, effective pressure is equal to atmospheric pressure, or none of these. I repeat the question. Quicksand condition occurs when the options are: effective pressure becomes less than 1, effective pressure reduces to 0, effective pressure is equal to atmospheric pressure, or none of these. Next question. Soils most susceptible to piping failure are. You have to tell me which kind of soil are more vulnerable to piping failure. The options are: inorganic clays, coarse sands, fine sands and silts, gravels. The question is, soils most susceptible to piping failure are. The options are: inorganic clays, coarse sands, fine sands and silts, or gravels. Next question. The line within a dam section below which there is positive hydrostatic pressure. The line within a dam section below which there is positive hydrostatic pressure. The options are: cutoff line, phreatic line, flow line, or pressure line. Those who have joined late, please write from the current question. Please unmute yourself. Start writing from the current question. When I discuss the answers, I'll just repeat all the questions anyway. You can follow them. Yeah, the question is, this is the third question. The question is, the line within a dam section below which there is positive hydrostatic pressure. The options are: cutoff line, phreatic line, flow line, pressure line. Next question. This is a numerical. Soil at the toe of a dam has void ratio 0.62 specific gravity, that is G equal to 2.62. Assuming factor of safety of 5, the permissible exit gradient is. Soil at the toe of a dam has void ratio 0.62. Just a minute, someone is joined. Yeah, those who are joining late, please write from the current question. The PPT is visible, right? And I'm audible, isn't it?
Yes, sir.
Yeah, okay. So write from the current question, those who have joined late. This is a numerical question. Soil at the toe of a dam has void ratio 0.62 and specific gravity is G equal to 2.62. Assuming factor of safety of 5, the permissible exit gradient is. The options are 1, 0.5, 1.05 and 0.2. Is this question clear? Is there any doubt about this question?
No, sir.
Soil at the toe of a dam has void ratio 0.62, G equal to 2.62, taking factor of safety equal to 5. Find out the permissible exit gradient. Next question. The value of hydraulic gradient corresponding to zero resultant body force is. The value of hydraulic gradient corresponding to zero resultant body force is. The value of hydraulic gradient corresponding to zero resultant body force is. The options are effective hydraulic gradient, total hydraulic gradient, critical hydraulic gradient, or zero hydraulic gradient. What do you call the hydraulic gradient at zero resultant body force? Effective, total, critical, or zero? Next question. This is an MSQ multiple select question, so more than one answer can be correct. Elevation of a point with respect to any arbitrary datum is called. Elevation of a point with respect to any arbitrary datum is called. The options are pressure head, position head, total head, elevation head. Elevation of a point with respect to any arbitrary datum is called. The options are pressure head, position head, total head, elevation head. Next question. Equipotential lines represent contours of. Equipotential lines represent contours of. The options are equal density, equal viscosity, same path, or equal head. Equipotential lines represent contours of equal density, equal viscosity, same path, equal head. Next question. This is also a multiple select question. The path along which individual particles of water seep through is called. The path along which individual particles of water seep through soil is called. The options are flow lines, path lines, traverse, or streamlines. I'll repeat the question. The path along which individual particles of water seep through soil is called. The options are flow lines, path lines, traverse, or streamlines. Next question. It is a true false statement. Grains in the soil below hydraulic structures gets lifted when the critical hydraulic gradient is greater than the exit gradient. Grains in the soil below hydraulic structures gets lifted when the critical hydraulic gradient is greater than the exit gradient. You have to tell me this statement is whether this statement is true or false. Again, those who are joining late, right from the current question, we'll follow up when we start discussing the answers. The question is, grains in the soil below hydraulic structures gets lifted when the critical hydraulic gradient is greater than the exit gradient. Is this statement true or false? Next question. The portion between two successive flow lines is called. The portion between two successive flow lines is called. The options are flow gap, stream gap, flow channel, none of these. Okay, for those who have joined late, I believe some of you have joined late. Will it be okay if I repeat the first 10 questions at the end so that you can solve? I believe Shudipta Paul, he has joined late. Navita Kumari, he also joined late. Do you want me to repeat the first 10 questions after I repeat all the after I dictate all the questions? Those who have joined late, I'm asking them.
Yes, sir.
Okay. Okay, after I finish dictating the questions, I'll just repeat the first 10 questions. Okay. The portion between two successive flow lines is called. I'll repeat up till here, okay? When I start repeating. Flow gap, stream gap, flow channel, none of these. Next question. The numerical. In a flow net, there are 4 flow paths and 15 equipotential drops. If the head loss is 3 meter and K, that is the coefficient of permeability, and K is equal to 2 into 10 to the power minus 5 meter per second, estimate the quantity of seepage in meter cube per second. In a flow net, there are 4 flow paths and 15 equipotential drops. if the head loss is 3 meter and k equal to 2 into 10 to the power minus 5 meter per second, estimate the quantity of seepage in meter cube per second. And by meter cube per seconds, it is implied that per meter width of the soil mass. Okay, so it is actually meter cube per second per meter. The options are 4.2 into 10 to the power minus 5, 2.2 into 10 to the power minus 5, 1.6 into 10 to the power minus 5, 4.2 into 10 to the power minus 4. I'll repeat the question. In a flow net, there are 4 flow paths and 15 equipotential drops. If the head loss is 3 meter and k equal to 2 into 10 to the power minus 5 meter per second, estimate the quantity of seepage in meter cube per second. Your options are 4.2 10 to the power minus 5, 2.2 10 to the power minus 5, 1.6 10 to the power minus 5 and 4.2 10 to the power minus 4. Next question. Again a true-false statement. For a two-dimensional flow, it is assumed that the porous medium is incompressible. Is this statement true or false? I repeat, for a two-dimensional flow, it is assumed that the porous medium is incompressible. True or false? Next question. Seepage pressure is equal to pore pressure, impact pressure of precipitation on soil, pressure exerted by percolating water on the soil, or none of these. Seepage pressure is, the options are equal to pore pressure, impact pressure of precipitation on soil, pressure exerted by percolating water on the soil, or none of these. Next question. A homogeneous earth dam is 52 meter high with 2 meter freeboard having 25 equipotential drops and 4 flow channels. If the coefficient of permeability is 3 into 10 to the power minus 3 centimeter per second, calculate the discharge in meter cube per second per meter length. Read this question carefully. If you have any doubt, please ask. A homogeneous earth dam is 52 meter high with 2 meter freeboard having 25 equipotential drops and 4 flow channels. If the coefficient of permeability is 3 into 10 to the power minus 3 centimeter per second, calculate the discharge in meter cube per second per meter length. The options are 0.00036, 0.00024, 0.0036, 0.0024. I'll repeat the question once again. A homogeneous earth dam is 52-meter high with 2-meter freeboard having 25 equipotential drops and 4 flow channels. If the coefficient of permeability is 3 × 10⁻³ centimeter per second, calculate the discharge in meter cube per second per meter length. The options are 0.00036, 0.00024, 0.0036 and 0.0024. Next question. Which one among the following is a scalar function of space and time whose derivative with respect to any direction gives the fluid velocity in that direction? Which one among the following is a scalar function of space and time whose derivative with respect to any direction gives the fluid velocity in that direction? The options are stream function, scalar velocity, potential function, velocity potential. I'll repeat the question. Which one among the following is a scalar function of space and time whose derivative with respect to any direction gives the fluid velocity in that direction? The options are stream function. Sir, please explain this question. Okay. Have you read about equipotential lines, flow lines, velocity, potential, stream function, potential, everything function, total function, complex function? Have you read these concepts?
Yes.
Yes. Two-dimensional Laplace equation. Have you all gone through these things? Yes. Who was the one who dropped a message?
Yes, sir.
Yes. So I believe this question means that among these four options, one is a scalar function of space and time whose derivative with respect to scalar function of space and time means space and time are variables. Okay. But the derivative of that function with respect to any direction gives the fluid velocity. Means if you take that function, suppose it is potential function, the scalar velocity, if you take that function and you differentiate that function, that is you find the derivative of the function, that derivative will be equal to the fluid velocity in that direction. Is it clear? When you differentiate a function, the result is equal to the fluid velocity. Clear? Mohammed, I think. No? Yeah. Is it clear? Mohammed Aram. If your mic is not working, please you can just write in the chat that is clear or not.
Yes, sir. Clear.
Yeah, okay, thank you. So among the following, which is a scalar function of space and time whose derivative with respect to any direction gives the fluid velocity in that direction? The options are stream function, scalar velocity, potential function, velocity potential. Next question. Portion between two adjacent equipotential lines and adjacent flow lines is called. Portion between two adjacent equipotential lines and adjacent flow lines is called. Options are field, gap, potential drop, velocity drop. the space between two adjacent equipotential lines and two adjacent flow lines. What is it called? Field, gap, potential drop, velocity drop. Next question. The hydraulic head that would produce quick condition in a sand stratum of 2 meter thickness if specific gravity, that is G, equal to 2.7 and E, that is void ratio, equal to 0.7 is. You have to calculate the hydraulic head, okay, that would produce quicksand condition in a 2 meter sand stratum thickness in which the specific gravity is 2.7 and void ratio is 0.7. Okay, the options are 0, 1, 2 and 3. I repeat again, the hydraulic head that would produce quick condition in a sand stratum of 2 meter thickness if G equal to 2.7 and E void ratio equal to 0.7. The options are 0, 1, 2 and 3. Next question. The critical hydraulic gradient for a loose deposit of sand having specific gravity of 2.67 and void ratio of 0.67 is. In the previous question, I asked you to find out the hydraulic head, and in this question, there is another sand stratum. I'm asking you to find out only the critical hydraulic gradient. Okay, so the critical hydraulic gradient for a loose deposit of sand having specific gravity of 2.67 and void ratio of 0.67. The options are 0, 1, 2 and 3. Next question. Please draw this diagram first. I'm explaining the main question. Draw this diagram and just write down the important parameters which you need. Okay, the question is, the sand stratum is overlain by saturated clay having unit weight of 18.5. Here you can see the sand stratum, right? This sand stratum, above the sand, it is saturated clay. This saturated clay has a saturated unit weight of 18.5 kilonewton per meter cube. At 8 meter excavation depth, water started entering the trench from below. Taking unit weight of water as 10 kilonewton per meter cube, calculate the height in meters to which water would have risen from the top of the sand in a borehole if it were drilled prior to the excavation. Is the question clear? You have to find out HW over here. Is the question clear? So there is a clay layer on top of this sand layer. Okay. Now excavation has been started, and once the excavation depth has been reached 8 meters, water has started entering the trench. That is, a crack has been formed on this layer, this clay layer, up till the 8 meter level. Okay. Now, at that point, what will be the height of water that will have risen in this borehole if this borehole was initially drilled before the excavation was started? Okay, so this is sand stratum with overall thickness of clay above it as 12 meter. Just a minute. Okay, don't take 12 meter. I believe it will be 12.5 because Z is given over here as 4.5. So it is 8 meter thickness and 4.5 meter. So take it as 12.5 meter. You don't need actually this 12 meter. This is HW. You have to find out HW. Gamma sat of the clay layer is being given as 18.5 and gamma W you will take it as 10. Okay, is this question clear? Is this question clear, everyone? Any doubt? Hello. Is this question clear?
Yes, sir.
Yeah, okay. So sand stratum overlain by saturated clay with unit weight 18.5 kN per meter cube. After 8-meter excavation, water started entering the trench. Unit weight of water is 10. What is the height in meters to which the water would have risen from the top of the sand in a borehole if it is drilled prior to the excavation? The options are 8.839, 7.328, 8.325, 7.632. All are in meters. Okay. Next question.
Sir, 1 minute, sir.
What?
Sir,
Yes.
yeah, 1 minute, sir. Will I complete?
Okay, you're completing. Okay. You just tell me when you finish.
Done.
Okay. So next question. Water is flowing at a rate of 0.04 ml per second in an upward direction through a fine sand sample whose coefficient of permeability is 2 into 10 to the power minus 3 centimeter per second. The sample thickness is 10 centimeter, cross-sectional area is 45 centimeter square, and its saturated unit weight is 1.93 gram per cc. Given these conditions, you have to determine two things. Number one, the head causing the flow in centimeters, and number two, the effective stress at the bottom of the soil in gram per centimeter square. If you have any doubt with this question, please tell. Water is flowing at a rate of 0.04 ml per second in an upward direction through a fine sand sample whose coefficient of permeability is 2 into 10 to the power minus 3 centimeter per second. The sample thickness is 10 centimeter, cross sectional area is 45 centimeter square, and saturated unit weight is 1.93 gram per cc. Determine the head causing the flow in centimeters and the effective stress at the bottom of the soil in gram per centimeter square. Please let me know if you have completed the question. If you have completed writing the question, I'll just repeat the first 10 questions for those who have joined late. Okay. Shall I go on repeating the first 10 questions? Yes. Over. Who is this? Who's unmuted, sir? Sorry, please mute. Okay, so this was the last question. I'll just go on repeating the first 10 questions. The first question was quicksand condition. The first question was quicksand condition occurs when effective pressure becomes less than 1, effective pressure reduces to 0, effective pressure is equal to atmospheric pressure, or none of these. Second question was soils most susceptible to piping failure are. Which soil are most vulnerable to piping failure? Inorganic clays, coarse sands, fine sands and silts, or gravels? Next question. The line within a dam section below which there is positive hydrostatic pressure. The options were cutoff line, phreatic line, flow line, pressure line. Then it was soil at the toe of a dam has a void ratio of 0.62 and specific gravity 2.62. Assuming factor of safety of 5, the permissible exit gradient is 1, 0.5, 1.05, 0.2. Next question was the value of hydraulic gradient corresponding to 0 resultant body force is. The options are effective hydraulic gradient, total hydraulic gradient, critical hydraulic gradient, or 0 hydraulic gradient. Next question was MSQ multiple select question. Elevation of a point with respect to any arbitrary datum is called. The options were pressure head, position head, total head, elevation head. Next question was equipotential lines represent contours of equal density, equal viscosity, same path, equal head. Then it was again a multiple select question. The path along which individual particles of water seep through soil is called flow lines, path lines, traverse, or streamlines. Next question was true or false statement. Grains in the soil below hydraulic structures gets lifted when the critical hydraulic gradient is greater than the exit gradient. Is the statement true or false? Next question. The portion between two successive flow lines is called flow gap, stream gap, flow channel. None of these. I believe everyone has written down all the questions. I'll give you time 10-15 minutes. I'll start at 5:55. Will it be okay? Yes. I'll start at 5:55. Okay. I'm giving you 12 minutes time. Solve this question, and if you finish, please write in the chat box that you have finished. Okay. Okay. Solve it. I think someone has joined right now. The session was from 5. The questions have been dictated. We're going to discuss the answers now. Have you finished the question? Those who are present from 5 after that. Ashok, Shakir. Okay, I'll be starting with the discussion part right now. The first question was quicksand condition occurs when? What is the answer? Anyone? Yes, what is the answer?
Zero.
0. Yes, effective pressure reduces to 0. Okay. Because when effective pressure can't be less than 1 because that will imply sudden liquefaction. But when it reaches to 0, that means the soil can get easily uplifted, and that is the quicksand condition. That means the soil is staying in its position, but it has lost all its shear strength. Next question: soils most susceptible to piping failure are? What is the answer? Which soil are more susceptible to piping failure?
Agni clay.
Clay, piping failure. For piping failure to occur, the soil must seep through it, right? There should be sufficient seepage. In clays, there is permeability, but seepage is rarely possible. Coarse sand, the path will not form. Yes, who was that?
Coarse sand, I think.
No, coarse sand, the path will not be found because if it is coarse sand, then the path will be broken because of discontinuity in the pore spaces. Again, same thing for gravels also, it will not be happening. Fine sand and silt. Quicksand condition, seepage, piping failure, these conditions are related to fine sand and silt because the continuation of pores will lead to the seepage of water through them, and only then piping failure can occur when the soil can seep through the soil, when the water can seep through the soil. So piping failure, the continuation of the pores is very important for the water to seep through, and hence fine sands and silts are mostly vulnerable to piping failure. Okay. Okay. Next question. Yes. Who is it? Any question you want to ask anyone? Shakir?
No, sir.
Okay. Okay. So first one was yes, this one was right. Second question. What is the answer? Line within a dam section below which there is positive hydrostatic pressure. What is the answer? No one. It is called phreatic line, isn't it? If you don't know it, then the line within a dam section below which there is positive hydrostatic pressure. It's called the top flow line or the phreatic line. Okay, that is the line which starts the flow of water into the dam section. Okay, above that, water is not flowing, and hence hydrostatic pressure is positive only below this phreatic line. Clear? Okay. Next question. Is this clear? Is this question clear? Yes, Ashok. What is your doubt, Ashok? He raised his hand and then he left the meeting. Okay. Is this question clear, all of you? Any doubt regarding this question?
Can you please
Can I please
once again?
repeat once again?
Question number 2, sir. Yeah.
Question number 2. This question. Piping failure.
The piping failure.
Yes, what is your doubt?
Yeah. Actually, I don't know this. The
You
piping.
don't know this. Okay,
It's perfect.
fine in just remember this, in fine sand and silt. Okay, for piping failure to occur, piping failure leads to the condition of leads to the quicksand condition. For piping failure to occur, the soil must flow upward. Okay, and for the upward flow of soil, then there should be continuity in the pores, right? If the pores are not consistent, if the pores are inconsistent, that means one pore is at this place, another pore is at this place, the soil can't move upwards. And inconsistent pores is what happens in pore sand and gravels. Okay, in organic clays it is highly cohesive soil, so it is permeable but not porous. But fine sands and silts, they are porous soils, where because of the fine particles of soil that can be uplifted by the water. And another reason is in pore sands and gravels, because of the larger particle size and particle mass, it is difficult for the water to uplift them. And in fine sand and silts, because of their finer particle size, it is easier to form a continuous flow channel and uplift the soil. Hence, these kind of soil, fine sands and silts, these are most susceptible to piping failure. Is it clear?
Yeah, sir. Thank you.
Yeah. Okay. And this is the phreatic line question. The answer is the phreatic line. Next question. Soil at the toe of a dam has void ratio 0.62, specific gravity 2.62. With a factor of safety of 5, the permissible exit gradient is. What is the answer? Have you solved this question? Yes, what? I can't follow you. Please.
Sir, is this same as this permissible exit gradient, sir?
permissible exit gradient. I can't follow you. Please write down your query in the chat box. Your voice is breaking.
And I'm telling, is this same
What is same? Is this same means same
permissible
with same what? Shakir, it is better if you write down your doubt. Is permissible exit gradient is my screen visible? Hello? Excuse me for the interruption. There was a problem with the internet. Sir, I mean to say is permissible exit gradient same as a critical hydraulic gradient? Yes, that is what I'm asking over here. I'm asking about the permissible exit gradient. So in this question, what will you do first? One. Who is this?
same multiple by
Amrita.
factor of safety?
Amrita is saying 1 and you are saying multiply. Okay, let me solve it. Wait. What is the critical hydraulic gradient formula? I see.
And
G minus 1 divided by 1 plus E. What will it yield? The answer is 2.62 minus 1, 1.62, 1 plus 0.6, 1.62, 1, right? But what is this 1? It is the critical hydraulic gradient, right? I'm asking about the permissible exit gradient. So factor of safety of 5. So exit gradient which is permissible, it will be IC divided by factor of safety. That will be equal to 1 by 5. That is equal to 0.2. Isn't it? Is it clear? Because see, if the exit gradient is high, then there will be a risk of piping failure. Okay, so I am introducing factor of safety of 5 in order to reduce the possibility of piping failure. So in this case, it is the critical exit gradient is 1. Okay, so if the exit gradient is above 1, then there will be piping failure. So to keep it much less than 1, I am assuming a factor of safety of 5, with which I'll get the permissible exit gradient of 0.2, which is much less than 1. With this value, there is minimum chances of piping failure. Clear? Is it clear, everyone?
yes, sir.
Yeah. So the answer is 0.2. The value of hydraulic gradient corresponding to 0 resultant body force is, what is the answer?
It's critical hydraulic gradient.
Yes, critical hydraulic gradient. The one we just solved in the previous sum. Next question. Elevation of a point with respect to any arbitrary datum is called. Any answer? What is the answer of this question? Elevation by point with respect to any arbitrary datum. Pressure head. We are saying pressure head.
No.
Then
That means the pressure term will not be there.
I am asking about elevation. That means you have to tell me the energy which the water will have just because of its position. Pressure head is the piezometric head, right?
Yes, sir.
The height to which the water level will rise in the piezometer, right? So that is ruled out there. Then what is total head? Total head is
It
what?
can be position head.
Total head is what? Total head
The
is
sum
pressure
of all
head,
heads.
sum
Pressure
of
head
all
plus,
the heads. What are the three heads?
plus the
Pressure head,
velocity head plus datum head.
yes, pressure head,
Velocity head and
position,
datum head.
yes, datum head. Datum head is also called position head or elevation head. Okay, with respect to any elevation, with respect to any datum, the elevation of a water, it can be represented in terms of energy as elevation head, and same thing, it is also called position head. So position head or elevation head or datum head plus pressure head plus velocity head gives us the total head, isn't it, Shakir? Is it clear? Is it clear, Shakir, Amrita? I go to the next question then. Yeah. Why your mic doesn't work? Okay. Next question. Equipotential lines represent contours of. What is the answer? Equal head. Yes. The line which joins all the points with equal energy, equal head, are called equipotential lines. Okay, so this question, the answer is equal head. We don't have any terminology for equal density or equal viscosity, or even if we have, I'm not aware of it. Same path, we call this as if there is a line. Okay, chalo, I'll discuss this in the next question. Same path, but equal density and equal viscosity, I don't think there is a terminology with respect to this particular chapter of soil mechanics. So the answer is equal head. Next question. Yes, the path along which individual particles of water seep through soil is called. What is the answer? Flow lines. Please write in the chat box your answer, because your mic, I think, is not working. I cannot hear properly your answers. Shakir is saying streamline. Amruta was saying something. Please write in the chat box, Amruta. Streamline. Yeah, streamline it is. Okay. This is a multiple select question, so there will be more than one answer correct. There might be. So any other guess? Shakir. Okay, the answer is Amrita, flow lines. Yes, both of you are correct. It is called flow lines and also called streamlines. Path line is just something I made up, and traverse is not related to soil mechanics. It is something related to surveying. So flow lines or path lines represent the lines along which individual particles of water seep through soil. Okay. So yes, same path, that means along the particular line, that this same path concept, this is the question for that, and the answer is flow lines and streamlines. Next question. True or false? Drains in the soil below hydraulic structures get lifted when the critical hydraulic gradient is greater than the exit gradient. True or false? Yes, flow line as well. This statement is true or false? Grains below soil in hydraulic structure will get lifted, that is piping failure, when the critical hydraulic gradient is greater than the exit gradient. True or false? If you don't know the answer, if you don't know the answer, just raise your hand. I'll just start discussing right away. Okay. See, in this question, where was the numerical? Yes. The permissible exit gradient was how much? It was less than 1, right? It was less than the IC. So this exit gradient should be kept less than the critical exit gradient, so that piping failure does not occur. Okay. Now here I have said critical hydraulic gradient is greater than the exit gradient. That is, I have said IC should be more than IE. So in this condition, piping failure will occur. So in this case, the exit gradient means the gradient following which the water is seeping out, but that is less than IC. That is less than the critical hydraulic gradient. So will piping failure occur? No, isn't it? Isn't it? Because when the exit gradient, when the normal condition is less than the critical condition, then failure won't occur. So IE, that is exit gradient, is less than IC, or IC is more than IE. So piping failure won't occur. Grains in the soil below hydrostructure won't get lifted. So this is a false statement. I have said grains in the soil below hydrostructure gets lifted when the critical hydraulic gradient is greater than. But in this case, in this condition, it is safe. Piping failure won't occur. Right? So this is a false statement. Clear, both of you? Is it clear, Amrita, Shakir?
Yes, sir.
Okay, fine. Next question. The portion between two successive flow lines is called. Is it? Yeah. The portion between two successive flow lines is called. What is it called?
Flow.
I don't get it. If my voice is audible to you, why is your voice is not audible to me? What is it called? Flow gap? Or flow channel? You said flow. I could only hear flow. You write in the chat box. Can't hear you. Flow channel. Okay, you have written already. Yes, it is called flow channel, but there is another name for this portion below two successive flow lines. Can you tell me another name? Flow channel or another name for flow channel is flow path. Okay. space between two successive flow lines in a flow net is also called flow path. Okay, next question. In a flow net, there are 4 flow paths, that is flow channels, and 15 equipotential drops. If the head loss is 3 meter and K is equal to 2 into 10 to the power minus 5 meter per second, estimate the quantity of seepage in meter cube per second. What is the answer? Have you solved this question? If you haven't, raise your hand. Amruta has raised her hand. If you haven't solved this question, raise your hand. Okay, I'm going to discuss it anyway. So, what is the formula for seepage for finding out the seepage? Is the quantity of flow. Q equals to
K
K
O
H.
H into N F by N D.
Yes, N F by. So you know the formula. Then what is the answer? So you put everything in this formula. What do you get? 4 by 15. It is 3. 2 into 10 to the power minus 5. I'll first write 2 into H is 3 into 4 by 15.
6 in
1.6, yeah, into 10 to the power of minus 5. 3 into 5, 15. 4 into 2, 8. 5 into 1, 5, 30. 1.6 into 10 to the power minus 5. This is the answer. NF is the number of flow channels or flow paths, and ND is the number of drops in potential, or the number of equipotential drops. K is the coefficient of permeability, and H is the head loss, which is causing the seepage to occur. You put everything in the formula, you get the answer. Okay. Next question. For a two-dimensional flow, it is assumed that the porous medium is incompressible. True or false?
true.
Why true? Because if
These are the assumptions of lab.
yes, assumption. What? Because of assumption? Because in a porous medium, if it is compressible, then with the increment in pressure or due to any amount of water pressure whatsoever, the volume will change. If the volume changes or it squeezes or expands, then the pores between them, okay, the pore spaces, the size will change, right? And if the size change, then the cross-sectional area will change, then the whole principle of seepage using Darcy's law will not be valid. Okay, so medium is incompressible, that is the size of the pores remains constant with time regardless of the water pressure. Whatever the water pressure is in this particular porous medium, and whatever the time it is, this particular porous medium is incompressible. Its volume won't change. So we know that the cross-sectional area of flow is constant. Clear? Is it clear or should I repeat once? Why it is considered as incompressible, assumed as incompressible? Is it clear?
Sir, once again, sir.
Okay. If the porous media is considered to be compressible, then the volume will change, and if the volume changes, the size of pores will also change. Okay, size of pores will also change, and if the size of the pores change, that means the cross sectional area through which the water is flowing, it is changing with time. Okay, so as per Darcy's law, we know Q equals to what? Q equals to K I A. If this area changes with time, can we apply this formula? No, we cannot. Okay, and this is the formula we apply when we try to find out the seepage and everything. Okay, so if the area of cross section, that is the pore size, is changing with time, then it will be difficult for us to calculate the amount of seepage. Hence we consider it is being assumed that the porous medium is considered as incompressible, so that we assume that there is no volume change, hence the size of the pores remains constant, and hence the area of cross section remains constant with time, for us to make the calculation of seepage more feasible. Clear? Is it clear now? Whoever asked the explanation?
Thank you.
Okay. What is seepage pressure?
Sir, pressure exerted
By
on the
percolating
soil.
water on the soil, right? Yes, pressure exerted by percolating water on the soil. This is called seepage pressure, because impact pressure of precipitation in the soil is not called seepage pressure. It is basically rainwater which causes runoff and infiltration. And equal to pore pressure. Pore pressure is static pressure. Okay, presence of water in the pores. It is seepage is when the water is moving through the pores in the soil. So that is not equal to pore pressure, which is static pressure. So pressure exerted by percolating water in the soil is called seepage pressure. Good. Next question. Yes. Homogeneous earth dam 52-meter high with 2-meter freeboard having 25 equipotential drops and 4 flow channels. So the coefficient of permeability is 3 10 to the power minus 3 accurate discharge in meter 2 per second per meter length. What is the answer? Anyone? What is the value of H over here? I cannot hear you. Please write down in the chat box. What is the value of H? What is the head causing the flow? Yes. The value of H is 52 minus 2, that is 50. Why? Freeboard means the gap which a dam has. So this is the dam, this is the upstream side. This is the height of the dam, it is 52. this is the freeboard. It is 2 meter. And if this is the downstream side, this is the water level on the downstream side, this is the water level on the upstream side. So the head causing the flow is, this is 50 minus 0, it is 50 meter. So you put the formula over here, 3, I will write into the power minus 3 later, 3 into 50 into NF by ND. What is NF? Number of flow channels 4 by ND. We have, this is 2, 6 into 4, 24. This is in centimeters, so 10 to the power minus 5, 24, 10 to the power minus 5 gives us this result, 0.00024. Have you all got
Yes,
this
sir.
answer?
Yes, sir.
Is this clear? Clear, or should I repeat?
No, sir. Clear.
Yes, okay. So freeboard, you have to subtract the freeboard from the height of the dam to find out the head difference, and then put in the formula to get the discharge in meter cube per second per meter length. Okay, the answer is B, 0.00024. Which one among the following is a scalar function of space and time whose derivative with respect to any direction gives the fluid velocity in the direction? What is the answer? Anyone? What is the answer? If your mic is not working, please write in the chat box. If you don't know the answer, please raise your hand. Do you know the answer? Anyone?
I
Write in the chat box. Right? If whatever you think, you write in the chat box, because I'm having difficulty listening to your voice because your voice is breaking. Velocity potential. Velocity potential. Y velocity potential is equals to phi, is equals to kh. Okay, so derivative with respect to any direction. So with respect to x, if I do del phi del x, k is a constant, so it will be k outside del h del x. What is this? Head by length, that is I, k I x. And what is ki? Ki is the velocity, right? Velocity in the x direction. So this velocity potential is a scalar function of space and time whose derivative with respect to any direction. Here we have found out the derivative with respect to the x direction, and it has given us the velocity in that direction. Okay, clear everyone? Is it clear, or should I repeat? Yes, Shakir, velocity potential. Okay, I'm going to the next question. In the same way, you can also find out the velocity in y direction by partially differentiating this with respect to y, that is del phi del y. Portion between two adjacent equipotential lines and adjacent flow lines is called. Any answer? Again, if you know the answer, write in the chat box fast. If you don't know, you can just raise your hand. Field. Yes, it is called field. This is two flow line and this is two equipotential line. You can see the difference. You can find out the derivative of the formula Q equals to KH NF by ND in any textbook. This is the portion I'm referring to. This portion is called field. Okay, this portion is called flow channel. Okay, and this is the flow line. This is the equipotential line. This is called field. Good. Next question. Hydraulic head that would produce quick condition in a sand stratum of 2 meter thickness if G equals to 2.7, E equals to 0.7. What is the answer? Two. How do you get 2? You first find out IC, right? Because for quick condition, the exit
Sir.
gradient would be equal to the critical hydraulic gradient. That is, it has surpassed the critical hydraulic gradient. So this is equal to G minus 1 divided by 1 plus E. 2.7 minus 1, 1.7, 1 plus 1.7 is equals to 1. And you are asked to find out the hydraulic head. So what is the hydraulic head? How do you find out the hydraulic head? What is the value of IC? IC equals to hydraulic head by length of traverse, or hydraulic head equals to IC into length of traverse. Length of traverse is 2 meter. 2 into 1, 2. The head is 2 meter. Clear, everyone? Is it clear, everyone? The question, how to find out the hydraulic head? Simple. Multiply the critical hydraulic gradient with the thickness of the stratum or with the length of the fluid flow. Okay, we'll find out the hydraulic head causing the flow. Next question. The critical hydraulic gradient for a loose deposit of sand having specific gravity 2.67 and void ratio 0.67. Very easy question. What is the answer? One. Clear, everyone? This is the value of the critical hydraulic gradient for a loose deposit of sand having specific gravity of 2.67 and void ratio of 0.67. Okay. Now, next question. I'll take some time in this question. If anyone has solved this, please raise your hand. We'll discuss it then. Has anyone solved this question? Has anyone solved this question? Whatever you have done. No. Shakir, you have solved this question. Okay. What is the answer you have got?
No, sir.
Okay, you have not solved this question. Okay, so those who have not solved this question, raise your hand. Okay, I'll discuss it. So, be very careful while you listen to this answer, the solution. You can find it in any standard textbook. This is, I think, previous year GATE question. Similar question was. Okay, so this is a sand stratum. This is a sand stratum, and this borehole was drilled before the excavation. Now, sand stratum has a clay layer of approximately 12.5 meter thickness. Now, excavation was started. Okay, and when the excavation depth was 8 meter, when up till 8 meter it was excavated, then water started entering the trench from below. That means water seeped through this clay layer and it appeared on this surface. Okay. Now, what is the height of this water? So, I have mentioned in the previous questions that piping failure or quick condition is found in sands, right? It is found in sands, and clay has a very less porosity to make the water transmit upward, or in any case make the pores consistent. So here, when this water is seeping upwards in this position, that means through the sand the water is going up, isn't it? Through the sand the water is going up, and in this case, when the quick condition occurs, the effective pressure is equal to 0, isn't it? The effective pressure is equal to 0. Now we are considering the effective pressure on the sand stratum. What is the effective pressure on the sand stratum? It is equal to the total pressure of this clay layer, isn't it? The total pressure of this clay layer minus the upward pressure exerted by the water. Okay, so if this clay layer in this position, in this portion, is 4.5 meter thick, so it will be the total pressure will be Z gamma sat minus, what is the pressure of water? Just at excavation up to 8 meter, the water has risen up to HW. So this is the water pressure at the sand level, right? This is the water pressure at the sand level, and into gamma W. Is it clear? This is the formula. Whenever you are being given sum like this, where sand stratum is being overlain by clay stratum, and after excavation there has been seepage of water at the trench below, because the water has risen through the voids in clay. That means here it has risen up to 4.5, but actually the pressure at the surface, the upward pressure, upward seepage pressure, is equal to the pressure exerted by HW, height of water. Because in this borehole, which was previously excavated before the actual excavation had been started, it was drilled prior in this borehole, because the effective pressure has reduced, the water has risen upwards. So this is the pore pressure at this level of sand stratum and clay stratum interface. And since we are considering the interface, we are considering the total pressure of the clay layer which is being exerted on the sand layer, because the clay is saturated. Hence Z gamma sat minus H W gamma W. This is the effective pressure. Now this is equal to 0. Hence we can find out HW equals to Z gamma sat divided by gamma W. Now tell me the answer. Is it clear, everyone? Hello? What is the answer? Gamma site is given 18.5. Z is 4.5.
8.325.
Yes. 8.325. This is the answer. Okay, just forget the answer. Is the concept clear? Why am I using gamma sat over here, not gamma submerged? Is it clear why am I using gamma sat over here and not gamma submerged?
So repeat once again.
Yes, I am considering the effective pressure on this sand stratum, above this sand stratum, right? So I am considering the pressure exerted by this clay layer. This clay is a different material, okay, and it is exerting pressure on this sand stratum. So total pressure of this clay layer on this sand stratum minus the water pressure, upward pressure because of this seepage will give us the effective pressure. Okay, because we are, see, what is the formula for effective pressure? Z into gamma sat minus gamma W, right? That means we get the gamma submerged, isn't it? Isn't it?
Yes.
Yes. So here we cannot use, after we use Z gamma sat of the clay, we cannot use Z gamma W. Why? Because the water has risen up to HW height and not Z height. Water is leaking, started to entering the trench from below, but it has been risen up to a height of HW. So if I use gamma submerged over here and don't use this, that won't be happening, because gamma submerged cannot be used with Z, because the water, the seepage pressure is being exerted up to a height HW, and because we are considering HW along with this Z, okay, hence for this portion we are taking only gamma sat, and entire portion we are taking gamma W. Is it clear? See, if we use, hello, is it clear?
Yes, sir.
If we use gamma submerged over here, if we use Z gamma submerged, how can we get Z gamma submerged? we have to take Z gamma sat minus Z gamma W, right, to get Z gamma submerged. So if we already subtract Z gamma W, we are already subtracting the water pressure up till this height, isn't it? Then this portion will be what? HW minus Z gamma W, isn't it? So if we take minus Z gamma W minus H W gamma W, HW minus, it is plus Z gamma W. Z gamma W cancel from both sides, we are left with Z gamma sat minus HW gamma W. Okay, so for this reason we are considering that total pressure of the clay minus the upward pressure exerted by water. Okay, is it clear, all of you? Any doubt regarding this question?
No, sir.
Yeah, okay. So this is a very important question for competitive exams also. Okay, last question. Water is flowing at a rate of 0.04 ml per second upward direction. Find sand. Coefficient permeability is 2. Sample thickness is 10 centimeter. Sample thickness is 10 centimeter. Cross-section area is 45. Area is equals to 45 cm square. Saturated unit weight gamma sat equals to 1.93. What is the head causing the flow? What is the answer? Anyone? Again, the same thing you can do. You can just raise your hand if you haven't solved the question. If you have solved the question, please write down the answer in the chat box. If you haven't solved this question, please raise your hand. If you have, write down the answers in the chat box. Amrita and Shakir have raised their hands, others are quiet. Okay. The first question is head causing the flow. Okay, so we know we have been given the rate of flow. Rate of flow is Q. We know by Darcy's law, Q equals to K I A. What is I? I equals to head causing the flow, is H by L into A. So you know Q. So what is the formula for H? H equals to Q L by K A. This is the value of K given over here, QL by KA. Now tell me the value of H. Substitute everything over here. Q is 0.04 ml per second, that is equal to cc per second, because 1 ml equal to 1 ml equal to 1 cc. So there is no need to do some extensive conversion for that. What is the answer? Value of H?
Four.
Only 4. 4 point something you got.
4.4.
4.44, isn't it? .44 centimeter. Okay, now effective stress at the bottom of the soil. So this is, suppose this is 10, this is Z equals to 10, and we have gamma sat. Now since this is a sand layer, just compare this question with the previous question. The previous question which I have given, there was a clay layer, okay, and water has risen above this layer. Now here what I am considering here, this is a single layer, single sand layer, okay. So the pressure due to this layer upon itself on this base, what is the effective pressure will be equal to, this will be equal to, since water is moving in an upward direction, we will be only considering the submerged weight, okay, submerged weight. So saturated unit phase is 1.93, so gamma submerged will be equal to 0.93, isn't it? 0.93. So first we have to find out the upward pressure, the upward stress. Upward stress is the flow of water, okay, the flow of water. It is, I believe, 10, no, 4.44. Yes, head of water, this is the head of water. So this is the head of water into gamma W. So head is 4.44 into gamma W is 1, it is 4.44 gram per cm square. Now what is the downward stress? Downward stress will be the grain to grain transfer of stress of this particular soil mass, because the soil is flowing upwards. This soil is saturated with water flowing upwards, so the saturation will have no effect on the effective stress. Only the submerged part will have the effect on the effective stress. That is equal to, what is the submerged unit weight? It is equal to Z gamma submerged equal to how much? There is 10, 0.93, 9.3 gram per cm square, okay, 9.3. So this sigma effective pressure will be equal to downward stress minus upward stress, and the value will be, I think it will be equal to 4.86 gram per centimeter square. Okay, is it clear everyone? Yes, what?
Part.
Which part? Why I have taken the submerged weight over here? Please write in the chat box fast, because I believe there is a problem with the internet. I have to stop the session now. Write in the chat box fast, whatever doubt you have. Shakir, I have taken submerged weight over here because this soil is saturated. This soil is saturated with water flowing upward. Part B, you repeat, sir. Yes, I have taken the saturated weight because this soil is saturated, and the water with which it is saturated, that water is flowing in an upward direction. So saturation will not have any effect on the effective pressure. Hence, we have to take gamma submerged over here, because only the grain to grain transfer of load will take part in the effective stress. Along with this, the upstream, the upward force, that is the H into gamma W. What is H? The head causing the flow in water, that is 4.44, and gamma W is 1 gram per cc. We get the upward force as 4.44 gram per cm square. Now what is the downward force? Downward force is the effective stress of the sand layer. What is the effective stress of the sand layer? Z gamma submerged. Z gamma submerged, because the value of Z is 10 centimeter, but the head which is causing the flow is 4.44 centimeter. Okay, again this is another sum where the thickness of the layer of soil is not equal to the head causing the flow. Okay, but the water is moving upward, so you cannot use Z gamma sat over here, because the saturation effect of the soil will never have any role to play on the effective pressure. It is this particular soil is exerting pressure on its own base layer. That means if this particular soil is exerting pressure on its own base layer, then only its submerged weight will be counted. If it was another layer on top of it, then its total weight will be counted. Suppose there was a clay layer above it, then the entire soil along with the water is exerting a pressure on this particular layer at the center or whichever part you display. So this particular soil, if it exerts pressure on this layer, then total pressure will be counted, because that is adding to its effective pressure. The saturated soil on the top of this layer is compressing this particular soil layer, increasing the grain to grain transfer of load, increasing the effective pressure. But when this is absent, when any soil layer above this layer is absent, then the effective pressure due to this particular soil layer is only incremented, is only effective due to the grain to grain transfer of its own load. Okay, and that is only equal to the submerged unit weight into the thickness. Is it clear now, Shakir?
3.3
Yes.
Z into gamma ratio. How we got this 9.3?
How you got 9.3? See, Z is equals to 10,
Yes.
and gamma submerged equals to 1.93 minus 1. Gamma sat minus gamma W, that is 0.93. And 0.93 into 10, we get 9.3. Clear? Z is 10, gamma submerged equal to gamma sat minus gamma W. Gamma sat is 1.93, gamma W is 1. So 1.93 minus 1 is 0.93. 0.93 into 10 gives us 9.3. Clear, Shakir?
Okay, sir. Got. Yes, sir. Got it.
Yes. So this sum is very important. This not this sum, all sums are important, but the last two sums are especially important, because you have to understand which sum to take the saturated unit weight and which sum to take the submerged unit weight. Okay, I believe you have solved all the question. If there is no doubt, I think I can dismiss the session. Any doubt, anyone, regarding any question? Okay, I think we can end the session now. Thank you for attending the class. Have a good evening. Chalo, bye bye.